Hello YouTube, this is Ready Set Exploit, and we're going to be doing second from TryHackMe, which is a machine I created where we find a website that is vulnerable to second order SQL injection. This allows us to extract credentials, which gives us initial access to the machine. We then find an internal website that is vulnerable to server-side template injection, which allows us to move laterally to another user. This user has write access to the etc host file on the machine, which we utilize to capture a login request. And lucky for us, the password for that login request also happens to be the root password, so giving us complete control of the server. So this was a fun room to create, and it was also a fun room to try to take over. So it was difficult in nature, because not because I wanted it to be difficult, but because just the topics, second order SQL injection, server-side template injection with a blacklist, they're difficult in nature. So without further ado, I'll go ahead and get started. So first, I'm going to go ahead and run an Nmap scan. So we have sudo nmap. I'm going to do a quick scan. So -b -min rate -min rate 10,000. 10.10.254.32 -b for all ports, grep open. And this will allow us to do a quick scan of the machine for any open ports. We have port 22, which we can guess is OpenSSH. We have port 8000, which is most likely an HTTP port, and that's all Nmap finds. So now we can do a more detailed scan with -sbc to run the enumerate versions and default scripts. Save it to a file called nmap.txt. The IP address -p22 and -8000, -p22, 8000, and this does a more like a more specialized scan, like on those direct scan on those particular ports. So that way it just saves us a little bit of time as opposed to doing the -p-. I'm gonna call this nmap. See, and it's over fairly quickly. Find port 22 is OpenSSH, running Ubuntu 8.2 p1, and we have an HTTP. Nmap tells us it's a work cert, which is a Python framework. A lot of times this is also Flask, so we can look into this. Can't really do much with SSH, so let's take a look at the web server, copy the IP address, fire up our browser 1000, and we have a login page. Let me make this a bit bigger. So now we can try just random credentials, admin, and correct username and password. We could run GoBuster on this. We could definitely sign up here. We can try that. Call this test user. Password test@test.com. Yeah. Sign up. Okay, we registered. We could do test user password, and we have some type of word counter. Let's count them. It's only one word, or 2 words, test user. Okay, so just a typical word counter, and it gives us back the name, which it's odd if you ever have used a word counter. Google word counter, this first one. There's definitely no login page. Well, there is here, but usually it just tells you the words and characters. This one tells us our name, and that's because of the login page. So that's the first thing to take note of. Now we know this is running workcert, recent server. We have a cookie here. Let's see, workcert Python. So it's workcert or Flask. So whenever I'm dealing with one of those, I usually like going for things like server-side template injection. But since we're dealing with a database, due to the login page, and it's telling us our name back, it's definitely worth looking into possible SQL injection. Server-side template injection is also reflective, so that's why I would try that next. If there wasn't a login page, I would definitely, well, they probably wouldn't have a user, but let's go ahead and log out. So first thing I'm going to do is I'm going to fire up Burp. Burp Suite, I want to capture every single request. And I'll cover why. Well, typically you want to, right? So that way you have every functionality of it. So let's go to history there. So let's sign up again. And do test user 1, password, test. I think we could use the same email. Actually, I forgot. Let's see, sign up. Oh, I guess we can. I am let's test user 1. Definitely bad. Not a great. Okay. So it didn't work. Probably can use the same email then. That would have been good if it told us that, right? Yeah, okay. So let's see. So just user 1, password at test123.com. Okay, there we go. Test user 1, password, sign in. There we go. So we should have captured every single request. There we go. We have the register here, sender to repeater. We have the login, send that to repeater. And we need the word counter. There you go, send that to repeater. Oops, there we go. There we go. So we have the register, right? Have the email here. Let's see, I think this was 123. Then we have username, logs us in, and we have the text box. And you know, a lot of different steps to get to where we need. So we can try an SQL injection. So we could do now 4, 5, 6. We can try a single quote. Right, and this will register. And now we can do a single quote here. And this is the part that is oh, okay. Didn't register for me. Oh, and it's probably because I made a typo before. So maybe the email does work. Let's do that. There we go. Okay. There we go. See? So we have a cookie now. Have to replace this cookie. And we get an internal server error. So we logged in here, right? Welcome to the word counter. And if you want to see that more real time, I don't want to capture too many requests. So I'm going to actually turn that off. Let's log out. So let's log in. Password. And we log in. But if we count it, we get an error. The error doesn't tell us much. But we could be dealing with a potential SQL injection because it errors out. And you could try different payloads. For example, we can try, if we want to prove our SQL injection theory, we can also try maybe registering or equals, we'll make this statement true. And this should spill out all of the users. I'm going to copy that. Registered. Let's go back to the main page. Password. Sign in. Let's count them. And we logged in. Gives us our user, but we only gives us the user, not the actual, not the whole thing. So we definitely did some kind of bypass. I should have tried a different password. That would have probably worked. So let's do it without any username, because that's what it's looking at. It's looking at test user or 1 equals 1, and test user 1 exists. So let's register that user. And let's log out. There we go. Password. I don't think the password matters. Actually, maybe it does. Let's try it. Nah, it does matter. password. So we count them. Oh, it errors out. So let's see. I probably okay. Let's see. All right. Well, we definitely know we have an SQL injection based on the query I did before, right? And I probably just messed something up with the quotations. Or 1 equals 1, and okay. Well, the next thing we can try, because we could just spend more time trying to get everything, but the next thing we could try is we notice how the username gets reflected back to us, right? Well, not here, but it tells you the username. So whenever something is reflected back, it's pulling it out of the database. And when I see that, I like to try union injection. And the point of union injection, it'll look like this. So if we do 1, union, select, then you try to enumerate the columns one by one, right? And then all the way, you keep going, all the way until you don't get an error anymore. And that is, that'll help us tell us how many columns there are, and then we can start which column is displayed on the page. It could be 2, it could be 3, it could be 4, and then we can extract the information based on that. But as you can see, it's tedious. We have to register, log in, post, copy the session ID and post, or do it on the browser. That's just a lot of work. Of course, if you're on a bit of on a race in terms of like, see in the call script. If you're in a bit of a race in terms of trying to get maybe like a first set of points, might be a bit faster, especially if your scripting is not strong. But even after you're done, or if you're not in a race, I think being able to put together a script to do this for you is very beneficial, because a lot of challenges with machine CTF, you will see import, we're gonna need string. Actually, we won't, because I don't know why I thought. Let's see, if name equals main, let's see, we're gonna go ahead and try URL equals sys argument 1. This allows me to just put the URL in the command line, so I don't have to keep editing it. And then we're gonna send it to a function called calls for columns with that variable. So except thing is index error. So if I don't put anything, I'm just gonna print like, I don't know, Python 3 calls.py HTTP target. You know, it's just for me, but it's good practice. So for example, calls, oh, what did I do? Oh, that's why. Anyway, in CTF rooms challenges, you're gonna see like, you're gonna see code here and there, and you may have to analyze it, or you may have to write something to complete the challenge. And it is very helpful. There we go. There's no function. It would be very helpful to have this skill. You don't have to be the best at it, just enough to kind of get you where you need to be, right? So now we have this. So this is where kind of everything's gonna come together, and this is why I took the request, because we're gonna need these. So let's see. So we're gonna call this previous. Equals, let me minimize that. So we're gonna do union select. There we go. We're gonna do, so for each column in range 0 to 10, right? So we're gonna go through 0 to 10. We could go higher if we don't find anything. If each column equals to 1, so the build, it's going to be previous string. We need to, so we're adding the previous here, and we're gonna add a string each column. I have to make it a string because otherwise it'll be an integer, right? Otherwise, let's see. Go copy that, paste it. So it'll be the previous plus, because if it's 1, I just need it to be a 1. And then otherwise I have to add a comma, right? So after 1 is going to be 1, then it's going to add, so the first iteration will be a 1. And then after that it's going to be 2, 3, 4, and so on. Right? So, yeah, okay, there we go. And then the final payload, it's going to be build plus, then we do the comments for the SQL query. And then of course the previous is going to be the build. So when we start again, this will now be like whatever the build was, right? Because we're adding the comments at the end. We could do some sessions. I think is request.session. Should check. Oh, WebLive was upgraded. So sessions, Python request. Let's see, Geek for Geeks. Yep, this is it. Perfect. Just copy that. Pretty sure that's what I typed, but let's. Oh, that is what I typed. Just in case I typoed something. Okay. So let's save that, because I guess I'd mess up. So now we could do, so the email is actually going to be, since we know the email can be the same, we could do test@test.com, and which is not great, but hey, you could also practice making random data. So now we need to register data. It looks like it is username, password, and email. So pretty simple. You could do username. I'm going to do, so that's going to be our payload. Password, it's going to be the same. Really should keep my quotations consistent. Email, it's going to be test@test.com. There we go. Close this. And now we gotta register. So register, register URL. So we're gonna do URL plus register, because that's the endpoint. Perfect. Next endpoint, and is username and password, login. And after that is login again. Whoever wrote this code is terrible, except pretty much it was me. So register, we don't need a session for this. We do request post register URL. We need the data, which is register data, and that is the first one. And I could do another function, but I'm just gonna do let's see, now we need the same thing. I'm actually gonna just copy this, because yeah, there we go. Perfect. So now it's gonna be login data. Don't need this, and it's gonna be the same except that this is gonna be login, and this is where we're gonna change. We're gonna do S, because this is where we need to build a session. Suppose do login URL, login data, and do, this is going to take us to home. And then we just need, copy that, there we go. And now we're going to do the box data, which I think is just text box. And this could be anything. Alright? This could be like whatever. And then we have that. Yeah, perfect. And the URL is the same. So now we do box, session post, login URL, data. We do box data. And then if box status code, let's see, does not equal, I think it was 500, right? Print box dot text. Actually, let's see, print, yeah, box dot text, and then print payload. And then we're gonna break. Now let's go ahead and do that. Copy the URL. Cols. Whoops. Gonna remove that and login URL not defined on line 42. URL. Oh, wait. Let's see. There we go. And I think it's going. Let's see. Oh, it worked. So there's only one word, to. And what does that mean? This is our payload that worked. So it's telling us that there are 4 columns, probably something like ID, username, because two is reflective. 3 is probably the password, 4 is probably email, or it could be email, 4 could be ID, you know, but spoiler alert, I believe it is ID, username, password, email. So, and what's reflected is 2. And this is great because now what we can do is we can build the injection. And I'm actually going to copy cols, I'm going to call it SQLI Py, and I'm going to just make a few changes. Import RE. You know, I'm going to do this. I'm going to do SQL script. And I'm going to run this again. And the beauty of this is that it'll still work because even though the users are already registered, I'm still forcing a login. And that's why, so there we go. And the reason why I want to do this is because I'm going to want to capture this. I don't want to have to go through the whole page every time. So there we go. So we have SQLI. So what do we need? I need sys. Let's see. Need request, need random. Actually, I don't even think I need random because I thought it would be a different email. I think I need it in the first place. There we go. I don't have to delete it from. So let's go ahead and go to the bottom. I'm going to call this SQLI. And we're going to need an injection. So we're going to do injection. Let's do databases. So the first payload we're going to do is we're going to do union select 1. We know it's 4 columns, so we're going to do select group underscore concat. We're going to do schema name. I'm going to need line breaks here. There we go. Because of the quotes, dash R, dash, and dash double quote again. So we're going to do from information schemata 3-4, and I'm playing it on the second column because that's the one that I know works. So injection, whoops, so it's still sending the URL, injection db. And I think this is called SQLI, injection db. Actually, I want to call this injection because I don't want to change it every time. So let's see, now we have to fix a few things. We don't need a for, we don't need to loop. So I'm actually going to go, let's see, I'm going to highlight everything. I'm going to move it. Don't need a for, don't need ifs. I don't need a previous, I don't need a payload. I need a session. And I do need an email. Register data is going to be the injection. And everything else will pretty much stay the same, except for you. And let's see, post, yeah, okay, that's good. And we don't need this. Yeah, there we go. Save that. So this is where the regular expression is going to come in. So I want something between this. I want everything between that and this. So we're going to highlight that. I'm going to copy it. And I'm going to do, let's see, call it search. Yeah. re.compiler r. There you go. That's what I want. Let's see. I think I messed that up. There we go. There. Now I'm gonna grab everything. Don't know why I put that there. There we go. And the next point I want is that. And now we're gonna close it. re.all. And we're going to do output equals search.search the text that we need, which is box.text, and then group 1. We're going to print the output, and I think that's it. And I'm going to just copy that. There we go. And we're going to run it. See if this works. And it did not. Oh. It's compile. Let's see. Ah, perfect. So there's only one word from me. So these are the databases. That's what I'm trying to extract. That was that payload. The payload was to extract databases. So we have performance schema, website, second project, development site. And we could go through each of these, dev site, but just for the sake of time, I'm gonna focus on website because that's our main target. And honestly, these won't really lead us anywhere. This one will reveal the second user, but password is useless. And this one will still reveal the same user. And the password that's revealed, the hash, it's uncrackable. So I don't just save you time. So with that said, let's go ahead and keep going. Let's see, now we need to extract his website, right? So let's go to the bottom. Let's do that. And let's copy it. Okay. We're gonna need 3 things. I'm gonna need tables, and then we're extracting the info. For now, use the mouse here, cheat a little bit. There we go. So now I'm gonna comment those. I'm gonna do injection tables, union select, There we go. This is going to be our main point right here. So we're going to do select group concat right here, and we're going to do now table name. Let's see, need this. Now break that up with a little column, and then we need column name, and we need another little break so we can break it up and do from information schema columns where table schema equals website. And this payload is probably going to fail. I'm going to do TV. Perfect. Okay. So, see, as I figured. All right. So it's actually email users. So we have the users table. We have email ID, username, password. So this is that's not giving us in the correct order, but that's okay. So we have users and we have username and password. So now we can comment this in case we mess up, and I'm gonna do final. And this is gonna be the extraction. Let's see, right there, select group concat, I went too far. It's gonna be, so we need I want the username separated. I want the password. I want to do a little line break. That's what these are. Yeah, so I want the username and password. I think I need one here. Yes, no, there. Perfect. And from the database, website, and the table. I think that's it. Let's give it a go. Let's see, where did I mess up? Right there. Here. Perfect. Let's do that. Whoa, okay, we have a lot. But that's the point of the extraction. So these are our union select. See, it was going 1, 2, 3, 4, and there we go. Register our users. The users we created before, and another user, Smokey, with the password, Smokey the cat. And we can try logging in as Smokey. Signing in. Doesn't give us anything, it's just a word counter. But that's okay. See, actually don't need this. I'll save it. Yeah, no, I don't need it for now. Close it just to save resources. So what we're gonna do is I'm gonna save these credentials. Smokey password. We did have a SSH. So we have Smokey at 10.10.254.32. Yes. Paste the password. See if we have password reuse. We do. Beautiful. SSH Smokey. Close this tunnel. We don't need that. And we have access to the server. So password reuse not great. What do we do now? Let's see. Is there another user? Okay. We have Hazel. Can we do any sudo commands? No. Any cron tabs for Smokey? Add reboot Python 3. So this is probably our site. So a little side note. This is so that we can start the site at the beginning. In the future, maybe there is a way to get remote code execution. I don't think so on the site with the word counter, because I forgot what plugin I use to be able to do that giant text box. You know, vulnerabilities happen. So if anyone ever does it, I mean, yeah, sure, they'll skip through the second order SQL injection, but they won't go anywhere past Smokey. So it doesn't really skip much. It'll just be weird unintended. But anyway, So that's our site. What else do we have? I always like checking the op directories. Oh, there's another file there. Okay, what site is this? We have, oh, this is owned by Hazel. Okay, let's see, ss-lmpt. We have a lot of stuff listening. We have something on 8080, we have the database, we have port 5000. This is ours. This is just MySQL again. So let's go to the opt and let's look at this site. Oh, apt. Let's clear it. And yep, port 5000. So that was running locally. Looks pretty similar. Register. Okay. So renders a template register, log out. This looks odd. Render template login. Okay, so there is a render template here, but the site is also being displayed here. Now, if you're familiar with Flask and such, password here, we can try more password reuse. This is the MySQL. This is a secret key that's used to sign the session key. But anyway, see, Flask. If you're familiar with, so this is the render template string. So this is safe, this is unsafe, right? And the reason why, you could see it here. So another thing is, we can look at the code, there's some kind of blacklist. Okay, selects a database. And WAF test. See, render template string, and it renders a message after this if. Should have been here. I think it's just some tab weird thing. So if we log in, welcome to the index page. So if you're familiar with Flask, and there's a vulnerability called server-side template injection, right? And this is almost like a second order server-side template injection, hence the theme second. So you have another second order. But if you didn't know, I'll show you how you could have possibly found it. So let's exit. Let's create a tunnel. So I'm gonna do -L. It's on port 5000. So we're gonna use our port 5000. That's what the first port is. If you're not familiar with tunneling, the target IP, which is the localhost, their localhost, not our localhost, and the port they're running on, which is 5000. So if it was running on another IP address, like another machine, we would put that other machine's IP. If we wanted to access this on our machine from on port 1237, we put 1237. So I'm gonna do, which I'll actually show more how this works later, because we're gonna have to do something like this. So, and a lot of people do get confused because the way to access this when you create a tunnel is through our local host. Whoops. But the target, and this, it would always be through our local host when you're doing a tunneling. So there we go. 5000, we could also do proxy change, but I'll keep it simple here. So it looks pretty much the same, except a wider background. Let's see, we have, can sign up. So it looks like it's the same functionality. So let's say you're here and you didn't know about, well, let's see what the site looks like. Probably there's nothing going on here, but let's just do it for the sake of completion. Test@test.com. Now sign up. We're gonna sign in. Test user password. Okay, so another display. So now we can look into, I wouldn't try an SQL injection here because we already have the database access. But we could do, let's say you didn't know. Let's say you Flask vulnerabilities. There we go. So remote, so we can look at this one, vulnerable Flask app, things like that. Hacktricks has a lot of it. So Flask, just a web server. So there's, you can always check for the debugger. It wasn't on here. So I think, okay, that's just the console. So let's see, there we go. So common vulnerabilities, access, SQL injection, command injection, but SSTI. So if you were not familiar with how to do this next step. So what is SSTI Flask? Right? So if you look at it, see, so we have something that's displayed. That's the route, render template, article text, right? And it just kind of goes about how to exploit this, just different ways. And see, for example, we could do something like this, right? So we could do SSTI, payload, all the things, server-side template injection. We look at Jinja, Python Jinja, Flask. So a good way to tell is by doing this. Let's log out. Let's sign in. You know what? Do a burp suite now. So this payload is the standard way of, or here, like you see there's this one. That one. So let's do, I'm gonna sign up. Test, no, password. Try to see if we could use the same email. All right, we can. It's great. So, password, sign in, 16. So it is vulnerable. It's multiplying. So that's a sign of server-side template injection. And we should hopefully have that in our history here. We do. There it is, 16. And we have the register. Send that both to repeater. It'll make a life a little bit easier. So there we go. So we could URL decode this. So let's see, URL decode all characters, because it'll still work. Oh, whoops. URL decode, URL decode. There we go. And let's see, yeah, perfect. So sign in, there it is. So you could code this up too, but this one's less involved. So let's, if you go down, you can do config items, and eventually you'll run into, you should be able to find one like this one, right? Just, you see we got some commands here. So let's go ahead and register this. Okay, registered. Do that. WAF test. You can render this. Just gotta do that. So that's what we saw earlier. There's some kind of like, there's something blocking us, some kind of like a web application firewall. And we see that here on the blacklist. Config self underscore and double quotes. If you just kind of kept reading down, it talks about different filter bypasses. Bypass underscore, this, and this one. There's underscore, commas, space, right? And it's, if you're doing a small comparison, didn't mean that. This, we're looking for config, self, underscore, and double quotes. So this one, if you look through it, there is no config, there's no double quotes, there's no underscore, there's no self. So this payload looks like it'll work. You also could have done SSTI, Flask, bypass. And this page right here, HackMD, also shows the same payload. See, bypassing as much as I possibly can, and this ties back to this. So let's see, we could do it that way. So let's try this payload. Why not, right? So let's see, we're going to register. Perfect. We have register. And then we're gonna put it there. Perfect. We are the Hazel user. There's our remote code execution. So anything that gets executed will be executed by Hazel. This is great. So let's create a shell. BI shell. Actually, when we do reverse shell Hazel. I have a little program, IP address, we're going to do bash. There we go. Now we're going to do rev shell upgrades. Let's see. Paste that in. Perfect. And we're going to do, I'm going to set up a listener. Perfect. Now what we're going to do is we're just going to change this to bash dev. And I'm actually going to do a little bit of URL here. Space. %20 means it's a space because there's just a lot going on. I could do a plus, but there's already a lot of special characters going on. Gonna register this, copy all this, register. Perfect, we got it. And now we're gonna upgrade. Okay, you could just, so it's Python -c import pty semicolon pty.spawn, then bash, Control C to background, tput lines semicolon tput columns, so we could get our lines, rows, and columns. STTY raw-echo semicolon, bring the process back. STTY rows 30, columns 128. This is so we can have better terminal wrapping, and export term equals x term. And we have access as the Hazel user. So we'll just keep that handy in case we need it. And if we go to our, I believe we're already there. We have our user flag and a note. But first thing we're gonna do is we have write access to the directory here. So that way we have some persistence. I'm gonna create a directory called SSH. I'm gonna do SSH-keygen -f. Need a name. No passphrase. There we go. .pub. So that generates to a public and a private key. Authorized keys. Clear this. IDRSA. That's the private key. This is so that we have access to two things. I'm going to do Alt-Shift-S, SSH, Hazel, IDRSA, paste this, hmod 600 IDRSA, add Nmap, I need this, SSH, so now we do Hazel at the IP address, and hopefully we log in. There we go, we logged in as Hazel. So now we have two shells as Hazel, comes in handy. So now the next step, we remember there was another site, but let's say you were stuck here. You don't. It's a lot of stuff going on. First thing is, if we remember there was a note. So let's read that note. Hello Hazel, please finish the second project site as soon as possible. Make sure that the WAF actually stops all attacks. And the reason that, well, yeah, so at least Smokey is telling Hazel to use the proper render template to avoid SSTI. So I wanted to kind of make a realistic story, so that's why I didn't include this note before, because it would have given it away. So you really should make your site secure, like my word counter. We know it's not. Also, I need you to put a pep in your step on that PHP site. So this is the first hint I wanted to drop, right? There's a PHP site, and Smokey's telling Hazel to rush, and it will be logging in to check your progress on it. So we know that Smokey is logging in, and I'll touch on this a bit later. Sincerely, Smokey. So that's the first hint of the next step. We already know that there is another site, one last site, 8080. Okay? If we curl that from here, 8080, we do see another site. We see fill your credentials, user login. Okay. Where is the site located? It's PHP, so it's most likely using Apache. You can confirm that by going to we could etc grab Apache. There it is. So we do ls etc Apache 2. We could check out sites available. Dev site, okay, there we go. Let's read that. This is the configuration file, and we see that it is listening locally on 8080. We knew that. We have the server name, so that means there's a host name of dev site and its location. So let's check it out. So let's say we do HTTP dev site 8080. We get the same page, right? We can confirm by doing MD5 sum. Okay. And we do the same thing, MD5 sum. They're the same, right? So we know it's the same site. So that's the second hit. But now what? What do we do with that? If you use a tool like, let's end this. There's a tool called Linpeas. This is a hard machine, so I'm assuming you're familiar with Linpeas, but I want to show it anyway. Go to Peas, go to Releases by Carlos Pollock. You download the Linpeas script, and you do Pspy by Dominic Brucker. This is to listen to processes, and it helps with cron jobs. And this is to enumerate the machine. So I'm actually going to use both. We're done the set for now. Actually, we're not, but for now. So I'm going to call this server. We're going to copy piece. I already have it on my machine. Copy it here. Pspy 64s. This is for 64-bit. Copy it here. ls. Set up the server. And here. I'm going to run one as Smoky. And we're going to do we get RIP address. There we go. Make sure my machine still has time. We do. Okay. And we're going to make this executable. We didn't have to. Could have just done Linpeas. And I'm going to save it. Actually, I'm not going to save it. I'm going to just run it from here, and I'll show you why. Because I already have an SSH access. So bash Linpeas. I'm going to let that run. And I'm also going to run, I'm not going to do it now. Actually, I am. 71? Yeah. Pspy. And that'll probably show up on Linpeas, but that's okay, because so we're not going to run this because it'll show way too much output due to Linpeas. But Linpeas, it's just like an enumeration script. Tells you what's going on, second host name, where Hazel. Tells us that it was vulnerable to this, it's not. Fun fact, when I first built this machine, while it was in review, it was vulnerable to this. So I had to patch it. So I'm glad it was found, because otherwise you would have been able to get from Smoky to root, no problem. But anyway, that's just a fun fact. None of these work. Going. This is AWS stuff. Progresses. And that's our cron job as Hazel. We already knew that because that's the file we found. Our path. And if you keep looking down, host named up. It also tells us the host etc host file dev site is local. So this would have been another hint as to what to look for the next step. Users, and there is something. It also tells us the Apache file, which we already knew. So Linpeas would have done some of the check for us. We already have this private key. We created it. But eventually it does point something out that definitely I think would have been, in my opinion, the last hint as to what to do next. And it's gonna come up right here. Files with access control lists. So in the Linux system, you could install access control list to do a specific access to a file. So it's saying that the etc host file has an access control list, and it tells you the user Hazel has read-write access. So if you're not familiar with that, you could do ACL Linux. It's gonna read up on it. This post right here does a good job. Essentially, you could just do more specialized usage, right? And it tells you what command to use. For example, remove. So it tells you get FACCAL. So let's see. Let's go here. Let's see if we have that command. We do. Host. We do. The user Hazel has read-write access, not Smokey, and only root can set this. So this would have been the next hint, because this would have been a little tough to find, you know, unless you like just randomly check for it. So Linpeas would have been crucial here, in my opinion. Otherwise, it would have been a little tough. But once you see it, that just means Hazel can write. Why would Hazel be able to write this? You know, there could be a lot of reasons. You know, I didn't want to make it so that it's too easy to find. Oops. Because if we look at the file itself, it doesn't say that Hazel owns this file. The admin group, and I could have made Hazel part of the admin group, but that also could have worked. But for now, the plus sign also gives it away. So just to get a more of a sort of a realistic feel, and just to have a good reason as to, because it would be odd to see Hazel here, and I don't think, at least maybe I'm doing something wrong. So if I do by user Hazel, type F dash writable, any errors, go here. I'm gonna ignore proc/sys because we don't need to know those. I don't believe this file shows up. So it's not name, it's user. So if we do user Hazel, type F, see, this file does not show up here. Therefore, even if we run this, we wouldn't have known. Even if we take writable out of it, it just doesn't show. So Linpeas, it's a great tool for finding things you may miss. But what can we do with that? Well, let's put everything we know we have, everything we have found so far. We know that actually now we can run Pspy, because I believe this finish. We don't want to run Pspy while Linpeas is doing this thing. And so what have we found so far? We know the note Hazel tells us that it's logging into a PHP site. We know the PHP site goes by dev_site.thm on port 8080, and we know Smokey is logging in regularly. How regularly? So in the real world, probably wouldn't be logging in that regularly. Maybe once a day, maybe once an hour, right? And there it is. There's a Python script off root. We can't read it because otherwise it would spoil the whole thing. And I try to name it something that was obvious, you know, as to not have to guess, but just be able to make an educated decision based on all the information. Called check site, right? Probably wouldn't be a script that checks the site, but I needed to emulate the human behavior somehow, just to give you an idea. And I'm gonna do this the easy way and the more realistic way. Actually, no, I'll do this the more realistic. No, yeah, I'll do both. That way, if you just want to finish, get this over with. So anyway, so this runs every minute, and we'll see that. So essentially what's happening is Smokey is probably logging in, and we can verify that. We could quickly go copy my IP address here. Okay. And there we go. So literally a minute after, it checks the site again. And I did that so that you don't feel like you're waiting forever. We're gonna exit. we're gonna go in again and remember what it was. So it was -L 127. No, we need a port. And we know it's port 8080, and we could use our own port, but we need to be able to listen on that port. So I'm going to do 1337. And this is so that we can see the site. This step is not required to actually get the root step, but it's so that we can actually have access to it. And should have logged in by now. Probably should check. So we're going to do 1337. And there we go. So you see what I mean? Because we can access it on our localhost on this port, and this is the target. All right. So if you're not too familiar with tunneling, so let's go ahead and set up a listener on 8080 for now. It's already in use, and that's because I have. There we go. And we know that, let's see, we can write on the host file. So dev site is set on localhost. But what if we set it to, and I know I just copied my IP address, I forgot to paste it, but it's okay. What if we set it to that? And just so that we know when it happens. It's not there? Oh, okay. I must have removed it. That's so silly. Let's see. We could probably just copy it again. There we go. I could use SCP, but this is just easier. So I always forget how to do it with. Oh, look, we have a request, so we probably don't need this. So this is the more unrealistic approach to verify, because if Smokey goes in and sees its site hanging, something's wrong. But I just want to be able to confirm it. So we do see a GET request to dev site 8080. So that's, we know Smokey's going in here. So the easy way to do it, just copy the page, because Smokey's expecting to see this page, right? So we're gonna do index HTML. Netcat won't work, but Python will. And we're gonna use Wireshark. Listen on ton 0, that's our address. And we could wait. Could also just keep track of, oh, we have a hit. Let's see, there we do. We have a post request. So let's just stop it, stop listening. And we have something here. You can click anywhere, really. But you'll see the HTTP requests. So let's right click, follow TCP stream. You have a GET request here. And see, that's the page. That's the page. And we have a username and a password, right? Which is URL decoded. You decode this password, and which I'll do after. And we have root access. But let's be a little more creative, right? Because if you actually access this site the way we have it, right now. So let's say we go here. If we actually, our site. See, if we try to log in, error response. We don't want that. We want to be able to, Smokey's expecting either invalid or to actually go on the site, right? So let's be more creative. So before, let's assume we haven't copied the address yet, right? Let's go to bar dub, because we know that's where that is, that site. And we have also, if you had checked the config page, we could also log into the MySQL service, but the password is hashed, right? MySQL page localhost Smokey -p. Let's see here. Let's see, and we can do -e. Select. Let's see. Show tables. Oh, let's see. Oh, database. I need one. Dash D dev site users. So if we do select all from users, you could get the hash, but this hash is impossible to crack, right? I made the test for super tough, which we saw earlier, right? You're not gonna find this in some word list. Anyway, that's not the point. So we just need 3 files. We need an index file, and I just need, because this is there's a lot of PHP stuff here. I just need this right here, and you'll see what I'm gonna do. I'm gonna minimize this too. I don't need that. So I'm gonna go PHP server. I'm gonna do make directory sites. Let's keep it separate. I'm gonna do index PHP, and I'm gonna do let's see. So I'm gonna close all this. Actually, right here. That's the header I want. And I wanna so right here. We don't need to validate credentials. So if the server method equals post, right? We are looking for a post request. Then we just go right to welcome.php. Don't need config. Don't need anything. Just that. And now we can copy this right here. Perfect. This is what it's gonna look like. PHP, so let's go here. Let's go to our own address. That's what that's gonna look like. Oh, okay. We could actually get rid of that. Let's see, invalid username, password. Let's see, let's just not put anything. Where's that div? We could probably get rid of it. Is that my own site? Let's go back. There we go. Right, so if we just enter a password, it takes us right to welcome.php. Beautiful. Next. Welcome. Just need this one. And we actually we don't need the PHP, we just need the HTML. Welcome.php. And we just have to edit this. We know it's going to be the Smoky user, so it's going to be hi Smoky, because we looked at the database. And here, instead of log out, so I don't have to, well, yeah, log out, in case, like, if we hover over it, I don't want Smoky to see, like, another site. So, log out. So actually, you're going to do copy index to logout.php. Because then that way, when Smoky clicks on it, it just, let's see where to go. It just goes right to the login page. So if we do that, hi Smoky, welcome to our site. So now it'll be up and running soon. Sign out. There we go. Right? So you see, if I hover over it, it just says log out. So it's completely fake page. A lot more realistic. And this is what we're gonna see. Post, get. Well, we're not gonna see the get log out. But let's go ahead and now listen on port 8080. Let's go back to Wireshark. Let's listen again. And oh, we just missed it. See, get, post, get welcome. You could also put a little PHP code to maybe capture the credentials after the post, right? see, have a minute, right? So I believe is, let's see, could do index. So here, see if this works. Could do file, put contents, creds, text, file, get contents, PHP, input. I don't know if it'll work, but we can try it. I don't want to spend too much on this. So now I'm going to actually go to here. I'm going to run Pspy. Ah, there we go. That work? Oh no, something else. Let's see. Right, is that the address? Let's see. I don't think it is working. Let's check it out. It's probably like, yeah. Oh, this is our reverse shell. Yeah, this is just our commands. Just gonna wait on the minute. Because when I execute the commands, it's still going through my, there we go. We have a hit. Did it go? File get, okay, so it just created an error. Yeah, so let's do that. Let's just remove it. It's not overcomplicated. Let's listen again. Let's have that running. And let's see, in 1 minute, we should be able to capture the credentials. So this is a more, in my opinion, realistic way if you wanted to capture the credentials, to Smokey was gonna see the page, go right back out, and we would have captured the credentials. It's more of a person in the middle approach. So, I did my best to kind of make this obvious. There we go. Get, post, get. There it is. So let's stop that. Go here. URL decode. There. Password. Sure. Hazel. Because we know Smokey likes to reuse passwords, there it is. We are the root user. And there's the check site script. There is the root users are flags. So that pretty much does the machine. So this was a lot, like I said, this was a lot of fun to create and to, try to test each step. Definitely had a lot of fun creating the second order SQL injection and setting something up to make the capturing of credentials as realistic as possible, as realistic as you could make it here. Little quick pro quos. I wrote these not entirely from scratch, just what I could find here online, and then having to edit it to match the environment. So whenever you're dealing with a machine, and I always check the background of the creator if possible, because if it's something that they wrote as opposed to using a CMS, not always, but there's a chance that they'll make unintendeds. I wouldn't be surprised there's an unintended way, in like either the site or the SQL injection. I'm always interested to know what other ways users are able to get to the same place. Feel free to comment, like, and subscribe. Hope you learned something, and I'll see you all next time.